Oops. I've got this posted to the website, but we'll just double check and make sure we're all good here. Okay. So here's the homework assignment from 8.1. It is not anywhere near as bad as it looks. Okay, and I'll show you some of those. Okay. We'll come back and we'll do 7.4 and 7.5 later. We're actually taking today and tomorrow to cover 8.1. Okay. So here's what 8.1 is. Okay, and my hope would be that if you struggled a little bit but kind of muddled your way through 7.3 and got mostly done or all the way done at this point, that this section will be easier than the last section. Okay, because what we're going to do is we're going to take that organized way of solving a system of equations. Okay, and we're going to keep track of things but in a very specific way. All right, so this section 8.1 is on matrices, systems, and row operations. So we already know what a system is. We've already done some row operations, some basic row operations. We're going to talk about what a matrix is. Okay? So we learned about row echelon form. And when we were putting things in row echelon form, it was a very useful form. But as we went through and did the work, you'll notice that we always kept things an X column, a Y column, a Z column, an equals, and then the answer column. Okay? But we had to write those over and over and over again. Okay, so we're going to kind of organize it a little bit different, in a little bit of a different way. So we're going to write the system in a matrix. And writing things in a matrix is going to make things a little bit easier to keep track of because a matrix is a rectangular array of numbers. A matrix is a rectangular array of numbers. Okay, and the nice thing, the word array, so we already know what a rectangle is. The word array is just short for arrangement. So it's a rectangular arrangement or a rectangular organization of numbers. And it just helps us keep our work organized. So you'll notice in this box right here, I'll make that a little bit bigger. It has an example of what a matrix is, and then we've got some things that we want to introduce, some vocabulary. Okay? So here's this big rectangle of numbers, and it says if m and n are positive integers, an m by n matrix, read m by n, is a rectangular array, in other words, a rectangular arrangement, in which each entry, and this says aij, a sub ij, of the matrix is a number. So every one of these a's right here, all of those are numbers. Okay? And it says an m by n matrix has m rows, horizontal lines, okay, and n columns. So whenever we're talking about a matrix, we always give the number of rows first and the number of columns second. Okay? So this is an example. This is actually a copy of what's in your book. And let's talk about more specifically and maybe in better terms what we've got when we're dealing with a matrix. So sometimes we call these the dimensions of the matrix. The dimensions of the matrix are the number of rows by the number of columns. Okay? And in this book, they call the number of rows by the number of columns, they call it the order of the matrix. So if somebody says, hey, what's the order of the matrix? They're talking about how many rows and how many columns does it have. A square matrix is a matrix with the same number of rows as we have columns. And we can use these words kind of interchangeably. Entries or elements. Okay? Entries or elements. If you hear either one of those words, we're talking about the same thing. We're talking about the individual numbers in a matrix. So what are these individual numbers here? Okay, and the indices or the index on a particular element, they are the subscripts that they indicate the position of the number in the matrix, the position of the entry in the matrix. And it's always rows before columns. So if we say, what is the A11 entry? that would be in the first row, first column. If we say the A22 entry, it's the second row, second column. A33 would be third row, third column. So 1-1 is right here, 2-2 is right here, 3-3 is right here because it's in the third row, third column. Let's look at this one right here. A31, it's in the third row, first column. It's just a way of that, those indices are just a way of indicating what the position is, okay? And if the row matches the number of columns, then we've got that main diagonal running down here, okay? And usually we talk about the main diagonal being on a square matrix, but you could have a diagonal being on any type of matrix, okay? Any questions there? So if you saw the homework assignment, it looks like it's pretty long. Some of the problems literally say this: identify the order of the matrix, and that's it. In other words, they just want to know how many rows and how many columns does it have. So this would be 2 rows, 1, 2, 3 columns. So we'd call this a 2 by 3. Those would be the dimensions or the order of the matrix. How about this one right here? 3 by 3. How about this one? Okay, 3 rows, 1 column, 3 by 1. And how about this guy right here? This would be a 1 by 3. Now, because this is just one single column, we call this a column matrix. And we call this a row matrix. Okay? Pretty easy, right? Okay, now, the other part of the instructions here were identify the A21 entry. So let's figure out what A21 is. And this book uses lowercase, and that's fine. Okay, I'll change it to lowercase in just a second. If I say, what's the A21 entry, or what's the A21 element, I want the one that's in the second row, first column. Second row, first column, it's this guy right here, it's a -3. That's the entry. What is it on this one? It's a 4. What is it on this one? A 16. And what is it on this one? A21 doesn't exist, right? There isn't one, because there isn't a second row. You want like 50 problems like that? Yeah. Pretty easy. Okay. All right. So the next thing we're going to talk about is, again, some more vocabulary: a coefficient matrix, an answer column, and an augmented matrix. Okay? So the coefficient matrix is a matrix that's made up, as you would expect, of just coefficients. So the coefficients here are 1, -1, -1, 4, -3, and 2, 2, -2, and -3. So the coefficients are just these 9 elements, or these 9 numbers right here. So here's what the coefficient matrix would look like. 1, -1, -1. Now, I write pretty sloppy when I'm writing in general, but for something like this, because it's important to keep them neat and organized, you'll notice that as I write these down, I'm keeping them so they're kind of aligned not only horizontally, but also vertically. And keeping these kind of in a nice organized fashion is going to be the key to you getting these right. There's the coefficient matrix. I need the answer column, so the answer column is going to be just the column of answers. So -4, 4, and -11. So here's the coefficient matrix. Here's the answer column. Now I want to write down something called the augmented matrix. Okay, when you augment something, you add something to it. So here's what we're going to do. We're going to take the two of these and we're going to put them together. So we're going to write it like this. We're going to write down 1, 4, 2, -1, -3, -2, -1, 2, and -3. That's the coefficient matrix, and I'm going to augment it with the answer column. So I'm going to write down -4, 4, and -11. Now, sometimes when you write down an augmented matrix, we'll do this. We'll draw a little dotted line here, or sometimes we'll draw a solid line here. And think about what this is again. This is a rectangular arrangement of numbers. And the way this is arranged is I've got an X column, I've got a Y column, I've got a Z column, and then I've got an answer column. So I've augmented the coefficient matrix with the answer column. That produces my coefficient matrix. Or sorry, my augmented matrix. Okay? What are the dimensions here? What's the order of this matrix? 3 by 3. This one? 3 by 1. How about this one? 3 by 4. Remember, always rows first, then columns. Don't mix those up. Okay, any questions? Okay. So the reason I wanted to do this section right after we did the last one is it builds right on top of it. And in my opinion, it's a little bit silly to do what we did in 7.3. It's very silly to keep writing those x's and y's and z's always in the same order. So what we do with an augmented matrix is we say, look, okay, instead of writing always the x's here and always the y's here and the z's here and having to write the pluses and the minuses and the equals and all that sort of stuff, we're going to reduce the amount of work that we have to do by reducing the writing. The idea is going to be the same, but we're going to put things in row echelon form, or we're going to talk about something called reduced row echelon form by putting them in a matrix and using those same type of rules that we did the other day with the row operations. So, again, the row operations are interchange any two rows, multiply a row by a non-zero constant, and add a multiple of one row to another row. Those should look very familiar. Okay? And again, to avoid frustration, let's fill this out again. What's the first thing? Go slowly. Keep things neat and organized. Avoid fractions. Go column by column, get the one first, and then use the one to make the zeros. Okay? And we also want to accomplish the goals in order, meaning get the one in a column and then use the one to make the zeros. Okay? Get the one in a column first and then use that one to make the zeros. Okay? Would you guys, after your experience yesterday, would you add anything to this list? Check signs. Anything else? Go even slower than slowly. Don't make dumb mistakes, stuff like that. Double check your calculations. What? Use the back of the book. Very nice. Thank you, Peyton. Okay, all right. So again, those rules and those ideas should look really familiar, but we want to take a look at this right here. And we're going to talk about row echelon form again, which we'll refer to as just REF, row echelon form. And then we're going to talk about something called reduced row echelon form. Okay? The nice thing about this one right here, and pretend this is an augmented matrix that represents a system of equations. What's nice about this right here is if this is the x column, this is the y column, and this is the answer column right here, what's nice about this right here, and is it in row echelon form? It is, isn't it, right? It's in row echelon form because we have ones down the diagonals and then zeros below. What's nice about this second row right here? X is 0, so this would be y equals whatever that number is right there. Y equals b. And then if you know what y is, you can plug it in right here and you can solve for what x is. So this is in row echelon form. You can just read off the answer. That's for a 2 by 2 system. For a 3 by 3 system, this one would also be in row echelon form. Again, ones down the diagonals, zeros down below. You could read off the answer. Z in this case would be C. You could plug that in here and figure out what y is. Plug those two answers in here and figure out what x is. Does that look familiar? The only thing we're leaving off is we're not writing x, y, and z. We just know that this is the x column, this is the y column, z column, and answer column. Okay? So it saves us a little bit of writing. It also makes it, if you're interested, it also makes it so you could just put it into a computer. A computer could easily handle the numbers and keep them organized. You could teach it the simple rules that we have up above for the row operations, and it could just do them for you. Okay? So that's the advantage of stripping off the variables and keeping things organized so we know what each one of those columns represents. Okay, now, compare what we had before with this right here. This is called reduced row echelon form. Reduced row echelon form. Now, think about why this might be nicer. This row looks exactly the same. You can read off that y would have to equal b. What's nice about this? Yeah, it's already solved. It means x has to equal a. So reduced row echelon form is even better than row echelon form because it's already in a format where we can read off the answers. This equation that's represented right here, no x's, no y's, z is equal to c. No x's, no z's, y right here, 1y would equal b. And on this one, of course, this would be x is equal to a. So if it's in reduced row echelon form, then we can just look at it and we can read off the answers. Now, I like putting things in reduced row echelon form. Okay? If you don't, at least get it in row echelon form and then turn it back into a system of equations and use back substitution. I don't recommend that. I think it's just as much work either way. And especially once you get used to it, I find it just as easy to do it either method. Okay? You will see this again, absolutely guaranteed. Okay, you'll see it next year when you take 1050. So if you know how to do it now, then you're in great shape. Now, I will say this. When I used to teach this in pre-calculus or in trigonometry, I would show them how to do this on a calculator. Your calculators will do this automatically for you. You could type it into a matrix and hit a button and it'll put it in reduced row echelon form and you can read off the answer. You're not going to be allowed to do that on a test. Okay, and that's not the point anyway. I mean, at that point, that's just doing voodoo magic in the calculator and giving you the answer, and you have no idea what it's doing. Okay, it will do the row operations, and I would teach students how to do the row operations because you provide the brain power, and the calculator does the arithmetic for you. Which I mean, we all know how to do the arithmetic. It just makes it so it doesn't make those silly sign errors and stuff like that. Okay. So I really like using the calculator, and depending on how quickly this goes, I may show you how to do that. But you will not be allowed to use it on the test, okay? And you are not allowed to use a graphing calculator in Math 1050, okay? That's not our decision. That's a college decision, okay? And you don't even get to use a calculator on exams in calculus, okay? Which I don't like, okay? But that's the way it is. Those are the rules that we have to live by, okay? So if we get done with this fairly quickly, I'll show you how to do it on the calculator, and it really is pretty cool, okay? Your thumbs are just going back and forth hitting buttons, and you can provide the brain power, a ton of brain power to solve a very complicated problem, but you don't get bogged down in the arithmetic and stuff, okay? Those silly mistakes that typically happen. Okay, everybody ready to do this one? Okay, so here's what we're going to do. We're going to put this one in reduced row echelon form. So we're going to make it look like this right here. It's also called Gauss-Jordan elimination. Gauss after Carl Friedrich Gauss. And there was another guy that kind of added on that. So in honor of them, we call this Gauss-Jordan elimination. It means just put it in reduced row echelon form. So the first thing we're going to do is we're going to write this as an augmented matrix. So I'm going to write this as 1, -2, 2, 3, -5, 9. Okay, and then I'm going to write down each one of the steps. And the goals are this. Everybody watching? Goal number 1 is to make that a 1. Done. Goal number 2 is to use the 1 to make a 0. Goal number 3 is to make that a 1 and then use that 1 to make that a 0. So I have 4 goals here. First one's already done. First thing I want to do is turn that into a 0. So I'm going to take row 1. I'm going to multiply it by -3 and I'm going to add it to row 2. What row actually gets changed? Row 2. I like row 1. I'm just going to write that again. Double check and make sure we didn't make any silly mistakes. Multiplying this by -3 makes -3, +6, -6. So this gives me a 0, a 1, and a 3. Right? Goal number 1. Goal number 2. Happens that goal number 3 is already done for us, so this isn't going to take many steps. Again, at this point, this is in row echelon form. You know what y is. You could back substitute and solve for what x is, But let's just put it in a reduced row echelon form. I'm going to do that by take row 2, multiply it by 2, and add it to row 1. And which row gets changed? Row 2 gets changed. Row 1 gets changed. We like row 2. We're going to change row 1. So I'm going to rewrite this. Draw an arrow here. So I've got a 0, a 1, and a 3. If I multiply by 2, I get 0, I get 2, and I get 6. Okay, I want you to notice something. By doing them in order, notice that this is a 0. So even if I go back and add it to row 1, it doesn't mess up the one that I made. And that's why it's important to do these in order. So I get a 1 here, I get a 0 here, and I get an 8 here. So this is in reduced row echelon form. So what's the answer? 8, 3. 8, 3. Any questions? On a 2x2, you have 4 goals. On this one, it happened that by doing step number 2, we also got goal number 3 taken care of. So it only took 2 steps to solve this one. Any questions? Okay, look at the bottom of this page here. Okay, I'm going to zoom in on this for just a second. It says, solve each system or state that it is inconsistent. Okay, so let's take a look at this right here. Why is it inconsistent? Yeah, this says 0 equals 4 on this last one, right? There's no way 0 can equal 4, so we would say no solution. We'd say this is inconsistent. What about the next one? Okay, it is consistent. Okay, it is consistent. It does have an answer. But what type of answers does it have? Has infinitely many. Okay, so this is the weird one where if you think of this one right here, this one says 0 equals 0. There's nothing that can screw that up. Which variable were we trying to find with this third row? We were trying to find z. So this means z can be any real number. Z can be any real number. If z is any real number, here's what this one meant. This one means y minus z equals 2. And this one means x plus z equals 5. So this is fine to say this, to say z is any real number, but I want to know what y equals. Y would equal 2 plus z. And what would x equal? 5 minus z. So if we were to write this down, we'd say it's the set of x's, y's, and z's such that x is equal to 5 minus z, y is equal to 2 plus z, and z is any real. Oops. Does that work? Any questions, any confusion about that? Okay. Let me show you one other way that you could write it. You could just write 5 minus z, 2 plus z, z any real. You could write it that way too. Okay, a little bit shorter that way. Any questions? Good? Okay. What about this one? What answer do I have immediately?
2.
What is 2? Z is 2. If I want to find y, This one would read y plus z equals negative 9. So that would be y plus 2 equals negative 9. Move that over. I get y equals negative 11. What am I doing here? What's this called again? We're just back substituting. Okay. This would be x plus y plus z equals 6. So this would be x equals 6 minus y minus z. So that would be 6 minus 2 plus 11. Is that okay moving those around? So that's going to give me 15, is that right? Okay. And there are my three answers. You can put them in as an ordered triple if you need to. Okay. So if we look at this problem again, this one is inconsistent. These two are consistent. These have answers. This one has infinitely many. This one just has one single point where the planes cross. Remember, that's what this is finding. It's finding the point where planes cross in three-dimensional space. Okay. We're pretty good there. Okay. All right. Flip the page over. It says solve the system using an augmented matrix and row operations. This one should look familiar. Okay, we're going to do this one using row operations, though, and we're going to put this in reduced row echelon form. So the first thing we're going to want to do is we're going to want to write this as an augmented matrix. So I'm going to draw an arrow, and here's what we're going to write. Okay, now I like writing them down in rows and then checking them in columns. So I'm going to write 1, negative 1, negative 1, negative 4, 4, negative 3, 2, 4, 2, negative 2, negative 3, and negative 11. Okay. I'm going to get your attention here for just a second. Okay, here's one common thing that I've found over the years that students will make mistakes with. Okay, the first thing is they're looking at this system and they're writing it on their paper. They write it down wrong. So what I do, again, I wrote them down in rows. I found the 1, the negative 1, the 4, and the negative 1 and the negative 4. Check them in columns. So let's check this last column. Is the last column negative 4, negative 4, 4, and 11? It is, so I'm in good shape, and I'm going to make it look like that's actually an 11. The next one, negative 1, 2, and negative 3. Good here. Negative 1, negative 3, and negative 2. Good here. And 1, 4, 2. 1, 4, 2. We're in good shape there. Everybody got that? Okay, now, here's the other thing that people make, and they get furious when this happens. Okay? If you look in the book, these problems are all right next to each other, and they all look the same. So unless you put your finger by the one you're copying, or grab a little sticky note and put it on there and cover up the ones around it, many times somebody will look at problem number 49, they copy the first two rows of 49, and then they copy the third row of 50. They go through and they do all the work, and they get the answer wrong. Because 49's in the back of the book, they look at it and they think, I didn't do anything wrong, and it takes forever to figure it out. So I've just spent over a minute talking about how to write this down, because it's important. If you don't start with the right numbers in the right place, you're going to get the wrong answer even if you know how to do this. Okay? So when you're doing the assignment, put your finger by the one you're copying down, and as you copy it down, you're looking back and forth. Okay? Everybody good there? And double check your work. Make sure if you write them down in rows, check the columns. If you write them down in columns, check them in rows when you double check to make sure you're starting in the right place. Any questions? Okay. All right, let's go ahead and do this one then. Here's what we're going to do. Goal number 1 accomplished. By the way, how many goals are there here? Nope. Not in reduced row echelon form. 9. 9 altogether. Get the 1. Use the 1 to make these zeros. So that's 3. Here's goal number 4. Make that 1. Use that 1 to make these 2 zeros. Then use this one, or find this one, and then use that 1 to make those 2 zeros. That's 9 goals altogether. I need to change all 9 of these numbers to be the numbers that I want, so 9 goals altogether. Okay? Got it? Goal number 1 done. We're going to do these a couple at a time because I think we can handle that. I'm going to take row number 1, I'm going to multiply it by -4, and I'm going to add it to row 2. So -4, +4, +4, +16. I like row 1. It's not changing at all, so I'm going to write that row down, leaving plenty of room, equally spacing these out. 0 here, 1 here, 6 here, 20 right here. Did I make any arithmetic mistakes? Now, why bother writing row 3 if I want to change that into a 0, right? So let's do 2 steps at once. I'm going to take row 1, and Cameron, tell me what I'm going to do with it. -2 and add to row 3. So if I multiply this by -2, I get -2, 2, 2, and 8. Again, row 3 is the one that's going to change, so I have a 0. Lo and behold, a 0, a -1, and I have a -3. Any questions? Pretty cool here. 2 steps. Goal 1, 2, and 3. 4, 5. What's my next goal? I want to use that 1 right here to make that a 0. I want to use this 1 to make that a 0. Now, before you look at this and say, hey, wait a minute, why don't we just turn this into a 1? Okay? You could, but remember I said it's much better if you do these in a nice organized fashion. Get the 1, go column by column, get the 1, use the 1 to make the zeros. We did that here. Next column, make the 1, already done for us. Make a 0 here, done. Make a 0 here. So how am I going to make that into a 0? Say that again. Okay, let's write it down the right way. We're going to do row 2 and we're going to add it to row 1. Remember, it's always that second one that gets changed. Okay? So if I do that, here's what I end up with, and I'm going to do the work down here. I end up with, that's a 1, that's a 0, that's a 5, that's a 16. I liked that row right here, 0, 1, 6, and 20. Now, should I write the third row down, or could I save myself a little bit of work by showing a little bit of work here? Couldn't I do this? Zero, 0, change to +1, change to +3. Everybody good there? Okay. Any questions? How many more goals do I have? 2 more. Okay, and I think we can do these in the same step. So I'm going to use that 1 to turn this into a 0. Now, does it matter whether I turn the 5 into a 0 first or the 6 into a 0 first? Doesn't really matter. Okay, it's the ones that you've got to do in that specific order. Okay, so I'm going to take row 3. I'm going to multiply it by -6, and I'm going to add it to row 2. And remember, I like row 3. I'm not changing that at all. These are zeros. 0 plus 1. That's a 0, and that's a 2. Last step. What is my last step? Take row 3. Do what with it? Multiply it by -5 and add it to row 1. Okay? So this would be -5. This would be -15. And if I put those together, and if I were to write these, those are just zeros, right? Still, because I multiplied those by 0. That's a 1. Still a 0. Notice how I haven't screwed up any of the goals that I accomplished earlier. This is a 0, and that's a 1. Okay, this is in reduced row echelon form. What we've done here is Gauss-Jordan elimination. We've put it in a format where we can look at the augmented matrix and we can read off the answer, because this is the X column, the Y column, and the Z column, and the answer column. I can look at this and I can say X is 1, Y is 2, and Z is 3, so I get 1, 2, 3, and there's my answer. Yes, this is the problem that we did in 7.3. It's the same one, but we did it using an augmented matrix. Rather than keeping track of the entire system with the X's, the Y's, the Z's, all the pluses and minuses, notice that we don't write any pluses here. Whatever the sign is in front, if it's a negative, we put it. If it's positive, we don't put it. So we're reducing the amount of stuff that we need to write. Yes, it's more abstract, okay? But in some respects, it's easier. We're just playing a game. Got these numbers and 9 goals to get in line. Okay, any questions? What's that? A sick, demented, difficult mathematical game. All right. Okay, so here's what we've got on the end of the page. And again, we've got today and tomorrow to cover this. So I'm going to look at a couple of these. We'll do through 45. If you can get started on the assignment, do all the easy stuff. Try a couple like this. This is actually number 64. It's very similar to one on your assignment. We'll start with that tomorrow. But some of the problems are literally this easy. It says, fill in the blank. Fill in the blank. What did they do to go from this one to this one right here? Multiplied it by 1/3, or divided that first row by 3, right? So what number goes here? 2. Okay? The command they would have done would be this. And they did that to make a 1 right there. Yeah, it made a fraction right here, but with a 2 by 2, it's not very difficult to work with. There is another way to make a 1 out of that. Very good. Okay, everybody watch, please. This makes a fraction, right? Yes, it gets goal number 1 accomplished, but it makes a fraction. Watch how you can make goal number 1 happen without a fraction. What if I take let's do this. Yeah, negative 1 times row 1, add it to row 2. Another way to write that would be R2 minus R1. Okay, row 2 is going to be the one that changes. So this would be a 1. We're going to subtract this, so that's going to be a minus 9. And that's going to be a minus 2. And this one would be 3, 6, and 8. Does that make sense? Why is doing this better than doing this? No fraction. And you might say, well, wait a minute. You wanted to get a 1 right here. Switch them. No fractions and switch them. Does that make sense? Okay? Take a look at this one right here. It says, identify the row operation used. Remember that big long list of problems that I said you've got to do from 8.1? Some of them are this piece of cake. Some of them are this. Old matrix, new matrix. That went from a negative 4 to a positive 5. That went from a negative 3 to a 0. That went from a 7 to a negative 5. Ideas? Cameron? Times this by 3, that would give us 9, negative 3, negative 12. So put these together, I'd get a 5. Put these together, I'd get a 0. Put these together, I'd get a negative 5. Is that the right operation? Yes, it is. Is that maybe a silly thing to do? Yeah, you probably wouldn't do that. They're just checking to see if you could. So we'd want to make this into a 1 somehow. Okay, that would be our normal thing here. And this one says, what was the original system? I mean, literally, what was the original system if this is what we had as an augmented matrix? What column is this? Y, Z. So this would have been, and I'm going to change colors here. This would have been X minus Y plus 2Z equals 4. This one would have been Y minus Z equals 2. And this would have been Z equals negative 2. That's it. Okay? Really quickly before you go. What would you do first if you had to do 64? Switch row 1 and row 3. That's the first thing you'd do. Okay? We will start tomorrow by doing number 64. We'll do example number 7, and then you'll have the rest of the time. Please get the easy ones done. Please get 7-3 done because you're going to turn that in tomorrow. Okay? And be ready to do these in